It says Terrace Gadgets wants to offer Deny an incentive contract to take over as CEO. So we identified this as a moral hazard question. We're trying to hire somebody, and it tells us some different information. It says the probability that the firm's value will be high if Deny works hard is 0.8. So F is 0.8. If she does not work hard, the probability that the value will be high is 0.3. So they've given us G. Usually G is 0. This time they give us G as 0.3. They tell us that WH and WL are going to represent the contract if the value is high and low, or low, respectively. It tells us that Dunai's utility function is U equals 7 minus 10 over W if she works hard, and U equals 10 minus 10 over W if she does not work hard. So this is a little different because usually they tell us a cost to hard effort, and it's usually a disutility cost. Well, this time it's kind of already factored into the utility function. Notice that this 7 kind of reflects that cost to hard effort because it's 3 less starting out than if she doesn't work hard. So this is a little different how they've given us the information, but it's no big deal. We're going to handle it the same way. And then it says Dunai's reservation utility is 5. So her utility at her other job is 5. They didn't give us a wage. We just have the utility that makes our life easier. The question says, with complete and perfect information, how much would Dunai have to be paid to induce her to work for Tara and to work hard? So we know with perfect information, we're going to set this up as her utility if she works hard is going to be equal to her other job. And again, this time, this is her utility function if she's worked hard. The 7 accounts for that disutility of hard effort, we can assume. We're going to pay her the wage with certainty, and we're going to set it equal to her reservation utility. And now from here, we're just going to solve for WC, which we find to be 5 in this case. The next question says, what are the participation and incentive constraints for Tara's problem with incomplete and asymmetric information? So we know that the participation constraint is going to be working hard at our job set equal to her other job. Well, working hard at our job, we're going to use the utility function of hard work, which is represented by that 7. 80% of the time, we're going to actually make the high wage. So we're going to have the WH in our utility function. 20% of the time, therefore, we're going to make the low wage. Or we're going to make low value and therefore get paid the low wage. And we're going to have to make that equal to 5. Notice that this isn't the same as we see on the answer choices. This is the right answer, but we do need to algebraically manipulate it to match one of our answer choices. So we can distribute through the 0.8 and the 0.2, and we can combine the 0.8 times 7 plus 0.2 times 7 is just going to give us 7. The 0.8 times this is going to give us 8 over WH. The 0.2 times that is going to give us the 2 over WL, and the 5 carries down. So a lot of the problems, a lot of the hard part to these problems is matching an answer choice. Know that you set it up right, and then be confident in your algebra to get to something that looks like one of the choices given. The selection constraint, well, it's going to be the same thing on the left as we had in the participation constraint, working hard at our job. But now on the right, it's going to be shirking at our job or not working hard. And we know there's a 30% chance of making the high wage, a 70% chance of making the low wage, but notice the utility function, we use the 10 because that represented low effort. And on the right side of the selection constraint, it's low effort at our job. So again, we're going to simplify this to make it match an answer choice given to us on the test. These next couple questions are pretty difficult, and you may be tempted to just skip them. And if you do see something like this on the test, it's a good idea to skip it to the end at least. Don't waste too much time on it. But it's doable, so let's read through it. It says, suppose Dunai's contract contains clauses specifying rules of public conduct for purposes of maintaining the firm's public image. If Dunai violates any of these clauses, the firm can just pay her WL and fire her and void the incentive clauses in the contract, right up to the day of the bonus is due. If value turns out high, the firm might therefore try to avoid paying her the bonus, and the bonus in this case is the difference between the high wage and the low wage. So WH minus WL is the bonus, by claiming she violated the conduct clauses, even though she will not actually violate them. If they do so, Dunai will take them to court. If she wins, she will receive a judgment of WH minus WL, so she'll get her bonus, plus P, which P is some punitive damages. It says, if the firm has no evidentiary support, so if they have no evidence of her misconduct, she will win all the time. So they would just not go to court in that case. However, if they do have evidence, there's a 50% chance that the firm will acquire that evidence, and that in that case where they actually do have evidence and they do go to court, 60% of the time deny will win. So a lot of these probabilities are confusing. We need a main step that we need to do is organize them and think about what's going on. The question says, if value is high and the firm acquires evidence of an apparent violation of the conduct clauses, the firm will fire or deny if blank. So first thing, we're assuming that the value was indeed high and they had that evidence. So the 50% of having the evidence isn't going to come into play, but the 60% of winning in court is going to come in play. So let's take a look at how that would. Well, they would fire or deny if not firing her was greater than firing her, because again, this is the cost to the firm. So if firing her was less costly, that's when they would do it. So we're going to have firing her on the right side, and we're going to make that less than not firing her. Well, first, what does not firing her look like? Well, we'll pay her WH. And now I've split this up so you understand what the bonus looks like. We'll pay her the base salary of WL, and then we'll pay her the bonus, which is the difference between WH and WL. Again, the minus WL and the WL are going to cancel, so really we're just going to pay her WH. Just understand that I split that up to kind of really draw that point. But now firing her, well, what does firing her look like? Well, we're going to have to pay K because we're going to go to court if we're the firm. 60% of the time we're going to lose in court, and we're going to end up having to pay her her bonus and her base salary, and also P, some punitive damages. 40% of the time we're going to win in court, and we're only going to have to pay her the base salary, WL, and then we'll fire her. So this is the right answer. Now we just need to make it match an answer choice on the test. So we need to combine like terms and distribute and manipulate this thing. So I'm going to leave the left side like it is. On the right side, I'm going to distribute through the 0.6 to the WH and the WL, and to the 0.6 distributed to the P. The 0.6 and the WL plus the 0.4 and the WL just give me that WL out there. So that made life a little easier, and we see that WLs are on both sides, so we can cancel them. And we can subtract, well, this is 1 times WH minus WL, and this is 0.6 times WH minus WL, so if we subtract 1 minus 0.6, we'll get 0.4 times WH minus WL. And on the right side, we'll have K plus 0.6P. So again, a lot of this work is just matching the answer choice to our work. But if you can set it up right, you're in great shape. You just need to do some manipulation to get here. This next question is again a little difficult, and we're going to actually draw a tree to help us organize our thoughts with this one. And we could have drawn a tree for the last one as well, and this tree that we're about to draw will help in thinking about the last one as well. So the tree is a good thing in this case. It says, assume the values of P and K are such that both Tara and Deny know Deny will be fired, and the parties will end up in court if the firm's value turns out high, and the firm has evidence of an apparent violation of one of the conduct clauses. Also, assume that F is 0.8 and G is 0.3 from the original setup above. From the perspective of the point in time when the incentive contract is signed, the probability of a lawsuit is blank. So I misspoke. We're going to draw the tree in the next one, but this one's just saying the probability of the lawsuit, and the tree would help, and we'll look at that how in just a second. But first, let's just think about this one plainly. It said that we're assuming the value turns is going to be, if the value turns out high, she's going to court. That's the first thing we assume. Well, how often is the value going to turn out high? 80% of the time. If she works hard, 80% of the time it's going to result in high value. Okay, well then how often are they going to have evidence that actually merits them going to court? Well, the probability the firm actually has evidence of a violation of conduct is 50%. So 0.5% of the time they're going to actually go to court of that 80% of the time. So we can conclude the probability that we end up in court is 40%, which is 0.5 times 0.8. Real fast, an assumption I made here why I wrote this, it says since the firm builds a contract to incentivize Deny to work hard, we know that 80% of the time the firm's value will turn out high. That's kind of a side note, but the contracts in the first place make it to where the firm knows Deny is going to work hard, therefore they're going to have to pay her that high wage, or they're going to have high value at least 80% of the time. That was one of the kind of subtle assumptions that we make. Okay, so this last one, it says, continue with the assumptions from the previous question. Which of the following represents the participation constraint for Tara's contracting problem in this environment? Again, the participation constraint is when we're working hard at our job, and we're going to make that greater than or equal to the other job. I just have greater than here, but we know it's greater than or equal to. In fact, we know we're going to set it equal to solve. And this is where I'm going to draw the tree. What does the other job look like? It's just 5 for sure. So on the right side, we're going to have 5. But what are we going to have on the left side? Well, there's an 80% chance we're going to have high value, a 20% chance we're going to have low value. When we have low value, we'll have the 0.2 times 7 minus 10 over WL. When we have high value, well, there's a 50% chance we're going to have no evidence, and there's a 50% chance we're going to have evidence. So when we have no evidence, they're not going to take us to court, and we're going to make that high wage. So 80% times 50%, we're going to make that high wage. So if you notice with the tree, what it helps is this probability is distributed to both of these probabilities. So that's why I have the 0.8 times the 0.5 right here. Well, with evidence, we're going to court. When we go to court, 60% of the time, deny will win. 40% of the time, deny will lose. So when she wins, so now this is where it gets kind of complicated because we have 3 probabilities. But again, this 80% is going to be distributed to everything on this side of the branch, or everything on this side of the tree, rather. So we have 80% times 50% times 60%, or 0.8 times 0.5 times 0.6. She'll win in court. So she not only gets WH, but she also gets P, because they did take her to court, they inconvenienced her, and they had to pay her the punitive damages. Well, that means 80% times 50% times 40%, she loses in court, and they only have to pay her, even though she worked hard, they have to pay her WL. So that's how I got all those probabilities. One very crucial thing is this plus this plus this plus this, all those probabilities have to add up to 100%. So that's one of our checks that we have to make sure is, does that add up to 100%? And we will see that it does. So let's write that out in equation form. And we have this. And we see that we can combine like terms because we have 0.2 times this whole thing, and we have 0.8, 0.4 times 0.5 times that same whole thing. So we can combine those two like terms. And we do that here, and we see when we simplify, that's 0.16 plus 0.2. That's going to give us 0.36 times 7 minus 10 over WL. And that's how we match it to one of our answer choices. Long, difficult, but that was the process we used to match it to one of the answer choices. So last we know that we have to make it match, and we see that 0.24 plus 0.36 plus 0.4 all times 7 is just going to give us 7. And then we can distribute through that 0.24, the 0.36, and the 0.4 to get 2.4, 3.6, and 4 respectively. And finally, that's how we matched that answer choice. So I know that was a long, crazy problem, but if you have patience and you draw the tree, would be very helpful in this one to me to organize your thoughts. You should be all right.